Okay, I want to review the rotation homework. This is 9-3 rotation, page 564, 565, 9 through 22. And the first ones we're just doing rotations, and the instructions told us to copy each figure and point P, draw the image of each figure for the given rotation about point P. And they tell us the degree measure that we're supposed to rotate for each one, and then we're supposed to rotate that figure. So number 9, we were supposed to rotate it 60 degrees. Okay, so I went through the process that we demonstrated yesterday online. I took my card, I found the distance from A to P, rotated it about 60 degrees to where P prime would be, and that's, or from to A prime, where A prime would be. And then I rotated point D the same way. I marked the distance D, turn about 60 degrees, and mark that distance again. See, doing each point one at a time. Then I marked the distance from P to B and rotated about 60 degrees, and then there was where B prime. So each one has rotated 60 degrees, 60 degrees, 60 degrees. Now, along with the segment, sometimes it may look a little more than 60, but it's still 60 degrees. And then you can tell, here's my rotated, this point, swung around here 60 degrees, that triangle to be that point. All right, the next one, it was a rectangle. Now, this one's not quite as hard because even though we're doing it 90 degrees, so when we mark the distance here and we rotate it 90 degrees, it's going to be here. See, that same distance at 90 degrees. So basically, when we rotated, it just turned our rectangle 90 degrees. Each point, though. This point rotated to here. This point rotated to here. This point rotated to here. I'm sorry. This point rotated here. This point rotated to here. Okay. This one rotated there, and this one rotated there. We could have used the rule on this one, because the rule for rotating 90 degrees that I gave you on this sheet. All right. See this point, if we say this is the origin, then we went over 2, up 4. This would be -2, 4. And using the rule, rotating 90 degrees, it's going to flip around and the first one's going to change. So it's going to be -4, -2. So -4, -2. So the rule even applied for this one, because this is in the center, P is in the center of our figure, so it would be like it's around the origin. So that rule even applied there, and we could have rotated each one. That's what your figure should look like. All right, the next one, number 11, we rotated this triangle about point P, and P was on segment BD here, like this, and we're rotating 180 degrees this time. So rotating 180 degrees basically means that where B was here, 180 degrees, B will be on the other side. So I just extended that segment, found the distance that B was from P, and then rotated 180 degrees here. Then D, which was on this side of P, rotated 180 degrees here. And then the one R that was not on the same segment, we can mark the distance that R is from P, and then I extended it up through that point like that, and then there's how far R prime would be. It's that same distance. And that's the way I did it. It went complete 180 degrees on the other side. So that's what your rotation should look like. Okay. The next one, number 12, we were rotating number 12, 90 degrees. Again, another 90-degree rotation like the one that we did before. So 90 degrees, here's point P. Point P is on our triangle. So if it's rotating 90 degrees, the distance K is from here, 90 degrees will be from here. See, that's a 90-degree angle right there. It's a right angle right here. So K was here. Now K is down here, the same distance from P as it was here. T moved from here all the way over here, 90 degrees. Okay, and then, of course, P stayed the same. So my triangle just went 90 degrees in that direction. Okay, just like that. So your picture should look, just like mine, or at least very, very similar. That show up as well. So anyway, okay, something like that. All right, the next one, starting with number 13. All of these, it said, copy each figure and point P, then draw the image of JK for a 180-degree rotation. So it's going to go all the way around point P. So we had this segment here, which would be JPK. That's what we started with. And P is in the middle. So all that's going to happen 180 degrees, J is going to swing around here and become K. So J prime will be K. K will swing 180 degrees this way. And K prime will become where J is. So that's 180 degrees. So it looks like the same picture, but really it's JK became J prime, K prime going in the opposite direction. For number 14, we had a segment. We had a point not on that segment. And I marked the distance that P was from J. And directly on the other side, that's how far J prime would be. 180 degree rotation from here to here. Same thing with K. Mark the distance from P to K. 180 degrees this way, and there's K prime. And then when I connect those, that's my segment. So the segment turned all the way around opposite and went in that, whoops, you couldn't see that, went in that direction. Okay, so that's number 14. Number 15, still 180 degrees, and I rotate each point. So there's really a segment. Let's see, I have the segment K, rotate 180 degrees, it's going to go in the opposite direction along the same line, and there's K prime, that same distance from here to here. Then I did the same thing with J. See, there's a segment from here. I can mark how far that is and flip it all the way around on the same line, and there's where J prime is. Okay, so it's 180 degrees. It went from here to the other side. It went, and then K went from here to the other side of P. So JK became J prime, K prime. So it turned it upside down as well. And then number 16, all we did is we had the segment JK, and P and J are the same. So 180 degrees, K is the only thing that moved to the other side. J became J prime because it's at the point P, and K became all the way down there on the other side. So that's what your picture should look like rotating. 180 degree rotations are not bad because you're just putting them on the other side, flipping them around. But remember, you're flipping each point. See, like on this one, this point went around P to this point. This point went around P to this point. And so they moved 180 degrees to the opposite side. All right, number 17, 18, and 19, you were to graph the quadrilateral that they had. And then we can apply the rules because we're rotating about the origin, okay? And again, those rules I gave you on the sheet, you can see I wrote the coordinates down here of the original, the pre-image, and the image. My pre-image is in pencil, okay? So the pre-image is here in pencil, and the image I put in blue marker so you can see where it went. So what happened, it was FGHJ, FGHJ, rotate F 90 degrees. So where it was 0, 3, now it's negative 3, 0. Okay, rotate G 90 degrees. Where it was negative 4, 1, now it becomes negative 1, negative 4. Because a 90 degree rotation flips the coordinates and changes the sign of the first one. Only the first one. See, so this negative 4, 1, when 1 comes in the front, it becomes negative, but the negative 4 stays negative. It just moves. Okay, so it's negative 1, negative 4. Okay, and then my H, which was 1, negative 4, the negative 4 comes to the front, becomes positive 4, 1. Positive 4, 1 would be the point. So each one of these points changes according to this reflection rule. And two, you think about it, this is a 90 degrees. If you were to do the same thing we did on our others, you could draw, the distance from here to here, turn it 90 degrees in the same distance, and you got that point. So it's still the same thing we do with all the others. It's just that when a coordinate plane, it makes it a little easier when it's around the 90 degree rotation. I listed all my points down here at the bottom so you can see how they changed. See, 0, 3 became negative 3, 0. Negative 4, 1 became negative 1, negative 4. 1, negative 4 became positive 4, 1. And then 3, 2 becomes negative 2, 3. The second rotation, number 18, was to rotate 180 degrees. So everything's flipping completely around. So we rotated 180 degrees about the origin. So F ends up down here, 180 degrees to the other axis, the same distance away. It was 3 on this side, it was 3 over here. Okay, H, it was up here, 180 degrees. That was at negative 1, 4. Now it's going to be at positive 1, negative 4. And then G goes from 4, 1 to, negative 4, 1 to 4, negative 1. And then J goes from 3, 2 to negative 3, negative 2. And so the rules applied for rotating, because what happens, the signs change. Both signs change. When you rotate 180 degrees, whatever XY was, now it's negative X, negative Y. Both signs change. Both signs change. That's why 0, 3 becomes, well, negative 0, negative 3, but negative 0 doesn't matter. Negative 4, 1 became positive 4, negative 1. The signs just change. The signs just change. The signs just change. And that's a 180 degree rotation. The next one was a 270 degree rotation, number 19. So we rotate 270 degrees about the origin. Okay. So the original is still in pencil. So F going 270 degrees goes all the way around. It was on this y-axis, so it's going to end up over here on the x-axis. Now, if you remember, I said 270 is going all the way around here. It's the same thing as going negative 90, going 90 in the opposite direction. Okay. So G was here, so it goes all the way around to this quadrant, or negative G to that quadrant. Okay. And same thing with the others. H is here, so H goes 270 all the way around here, or negative 90 in that direction, and so on. And then there's my coordinates down here. So what happens with a 270 degree rotation? Well, with a 270 degree rotation, we flip them around and change the sign of the second. So you flip them around, change the sign of the second. So this flipped around, and the sign 0, its sign change, you really can't tell. You flip this one around, you change the sign of the second. See, it was negative 4 here, so it's going to be positive 4 there. You flip it around, change the sign of the second, it becomes a negative 1. Negative 4 remains, but it's a negative 1. You flip them around, 2, and then the 3 becomes negative. So those are the rules. But, you don't have to do the rules. You can just remember how we've rotated everything else. Same distance, at an angle, and 270 degrees is an easy one to determine, especially within a coordinate plane. 90 is an easy one to determine within a coordinate plane. 180 is an easy one to determine in a coordinate plane. So that makes it fairly easy. All right, number 20, you're doing a 270 degree rotation about the origin of triangle PRS. I graph PRS. Here's PRS, PRS. They didn't even tell you to graph it. You just needed to apply the rule, actually. Remember, it turns around and the sign of the second one changed. So this 2 comes in front, the 3 goes in the back and becomes a positive 3. Turns around, change the sign. So where P was here, remember, 270 degrees all the way around here, or negative 90. So if it's at 3, 2, now it becomes 2, 3. Oh, it's negative 3, 2. Now it becomes 2, positive 3. Okay. R is at 2, 4. It goes all the way around, becomes 4, negative 2. And S stayed in the same place because S was at the origin to start with. So you can see the change in the coordinates, and you should also be able to see how it moved. Now, they didn't tell you had to graph it. All you had to do is come up with those points using or applying the rule. All right, number 21. Number 21, we're taking, now this is a little different because they give us the coordinates of the image, and we're supposed to give them the pre-image. So we started again, I started with the pencil drawing. Okay, you didn't say you had to graph it, but I started with a pencil drawing, and this is what would have been rotated. The blue one would have rotated 90 degrees to give me the pencil drawing. So these were the coordinates of the of the image, and we had to give them the coordinates of the pre-image. So we're going backwards. We're just absolutely, reversing it. If we think of this as negative 1x, and we flip it around, and they both become, the signs change on the first one, so we're just flipping them around. So negative 3, 2 becomes 2, positive 3, okay? Because we went from V being here at negative 3, 2 to being here at positive 2, 3. It was a 90 degree. See, it's almost doing a 90 degree going the other way. This is the pre-image. We can think of a negative 90, or you could think of a 270. It's the same as a 270, the rule would be, because we started here and ended here. So they're giving us the end point saying, what did we start with? Okay, so it's in reverse. It's backwards. And those are the coordinates that I get when I reverse it. So because I'm reversing it, going from the image back to the pre-image, it's a negative 90 degree rotation. Okay, it was a positive 90 degree from here to here, but we're going backwards, so it's a negative 90 or a 270. And the last problem, number 22, speaks of a Ferris wheel. It said we had this Ferris wheel, and it's drawn on a coordinate plane so that the first car is located at the point 3, 0. What are the coordinates of the first car after a rotation of 270 degrees? Well, 270 degrees, what do? We flip the coordinate around and change the sign of the second one. So if it was at 0, if it was 30, 0, it would have started way out here somewhere. 270 degrees is going to go all the way around to here. That's going to be 0, negative 30. So if you just think about how it rotated in the coordinate plane, it was on the x-axis at 30, 0. It's going to go 270. It's going to be on the negative y-axis at 0, negative 30. That would be 270 degrees. 3 90-degree turns. Okay, so that's the homework from the rotation, and hopefully you understood what you were doing and you did a good job.